back. Today, we are going to take a look at data types and variables in Rust. By the end of this video, you will have a solid understanding of all the data types available in Rust. So, what are data types? Data types are used to define what kind of data we can store in our variables. In Rust, there are two main categories: primitive data types and composite data types. Primitive data types include integers, floating point numbers, booleans, and characters. I have listed string here as well, but it's not a primitive type. But for the sake of simplicity, let's count it in basic ones. On a composite side, we have arrays, tuples, slices, structs, enums, and more. Utility types are the ones which are used more frequently. So I have listed them here as well. Let's first take a look at the primitive data types. So the first primitive type is integer number. It can either a signed number or an unsigned number. As you can see, integer number is either prefixed with I or U, followed by the size of the number. For example, I8, it can store a number which fits in 8 bits. Similarly, I128 can store a number which fits in 128 bits. I represents a signed number and U represents unsigned number. Last type in both signed and unsigned ends with word rather than a number. It means it depends on the machine. If you are using a 32-bit machine, it will store at max 32 bits. Similarly, if you are using 64-bit machine, it can store 64-bit number. And the floating point numbers are represented by either F32 or F64. F32 is basically a single precision number, which requires 32-bit space. Similarly, F64 is a double precision number, which requires 64 bits space. And the booleans, it is either true or false. And the keyword to represent boolean variable is bool, B-O-O-L. A character data type represents a Unicode value, which means character type in Rust can store any character from any language. You can store English, Hindi, Japanese, or even Chinese characters in character type. But it's not limited to just letters and numbers. You can even store emojis or any character which can be represented using Unicode. Coming to the string data type, it's a special one. It's not really primitive data type. We will look at it in depth in future videos. For now, just remember that it's represented using either and str or the word string. And str is string slices, and string is a global heap allocated UTF-8 encoded string. We will look at it in depth in future videos. Let's write a simple program to see how to use these data types. Today, we are going to use Rust Rover ID. You can use it free of cost for non-commercial products. Let's create a new project in Rust Rover. Click on this new project button, then provide a name to our project. Let's call it ch02 underscore data underscore types. And let's hit on the create button. Okay, now our ID is open. So the way to create a variable in Rust is using word let. Okay, the name of the variable 5 plus 10, and that result will be stored in variable sum. Let's add a few more simple calculations in here. Let's do the difference, and I'll go with the suggestion. Let's calculate the product, which is multiplication quotient. Let's add let's see how it works when there is division operation and number is truncated, and reminder as well. Okay, and let's print all of these calculations on the screen so that we'll understand how it is working. Okay, and the way to do that is print ln statement, and inside that we'll have a string, and this is where we are specifying a placeholder which will be replaced with a variable, and that variable will be sum. So second argument is basically the variables. Let's add other variables as well. Let's take a look at the code that we just wrote and try to understand what it's doing. The first line that we wrote is let sum is equal to 5 plus 10. In Rust, all integer numbers are by default I32, which means 5 is I32, 10 is I32. So the resulting operation type will mostly be I32. On second line, we are using the fractional numbers. And same as integer, the default type of floating point numbers is F64. As both numbers are F64, so the resulting operation is F64. And that's the reason we are seeing F64 in front of difference. And same goes for all other operations as well here. Now let's mix the types in calculation and let's see how Rust treats it. So let's create a variable a is equal to 10. which is going to be the I32 variable because we are not specifying the type and default type is I32 for integer numbers. Let's create a second variable and we are going to specify the type this time and it is going to be u32. Now, as soon as you write c is equal to a plus b, the line a, it changed from I32 to u32 because the operation involves u32. So Rust automatically considers the type of a is going to be the u32. So the end operation is going to be the u32. And if we print it, we'll get the result. Let's run the example and you can see overall sum operation is 10 plus 20, which is equal to 30. Before we move to floating point calculation, let's take out our snippet and put it in a separate function. Okay, let's select everything, cut, and let's create a separate function. Fn. Fn is the word that we use to create a function, integer type. And then let's put everything in integer type. Now call this integer type function. Let's copy the name of the function and let's call it inside our main function. And let's put a println statement in here so that whenever all these operations are performed, we can know that it is of integer type. Okay, let's move on to the floating point calculation. For that, let's create one more function. Let's add the println statement and let's introduce a variable. Let x is equal to, let's say 2.0. Here, as you can see, all the floating point numbers in Rust are of F64 type. That means you don't have to specify F64 in here. The Rust will implicitly put the type for this variable, which is F64. And for F32, you have to specify it explicitly. Let's say I want to create a variable of F32 type. Then in that case, you have to say let y, then the colon, and the type of the variable. So in our case, we are saying my variable y is going to be of type F32. The value will be 3.0. Now we have the variables. Let's perform a couple of operations and let's add the print statements now. Let's print and see what will be the result. And let's print the calculation as well. Now let's use this function inside the main function so that it will be called. Now let's run the example and we do have the result for the floating point calculation as well. For Boolean values, we'll create a separate function. Okay, let's add one println statement. Let's introduce one variable in here and then let f is equal to, and we'll specify the type explicitly. Even though Rust infers it automatically, we are going to specify it. And let's add these println statements. The value of t and f will be printed. Let's call our Boolean type function from the main function. Let's run it and let's see the output. Great. So we are able to see the value of T and F, which is true and false. Now let's use the character type again. Let's create a separate function for the character type and let's add one character. So we are going to use the Z character, but this time we are going to use the Unicode for it. Okay, so this is the character that we are going to print. And why to stop there? Let's add emoji as well. Let's add the emoji. Okay, so we do have a cat. And let's print everything. And we want to print this one as well. Perfect. Now let's call our function from the main function so that we can see the output. Let's run it. So we can see all the characters in our output. Okay, now we have the string type. Let's create a separate function for the string type. Let's add the println statement and let's introduce a variable for the string type. Okay, and we are going to create one hello world string. Now, if you notice, the type of this hello world is and str. Let's introduce one more string variable. And this time we are going to use string colon colon from and we are going to add something in here. Now we have two types of strings. One, it says hello, and other one, it says welcome. Okay. So the type of this hello world is and str, and type of the welcome is string, capital S string. So these are the two ways to create a string type. The first one will be stored in stack or in binary file itself, and the second, this one will be stored in the heap memory. That's the difference between and str and string type. Let's print both the strings, and this time we're going to use a different print statement. Okay, so I'm going to say hello. If you notice, I'm going to use the variable name in here itself. Okay, so you can basically avoid passing the variable names in here, and you can directly pass them inside the placeholder. Before running, we have to call the string type in our main function. Let's go to the main function and let's call our string type and let's run the program. Great. We are able to see our string output. Hello there. Welcome to Connect Thread. Perfect. So that's about the basic data types. But there is a small problem with our example snippet. We have everything in a single file. So let's do some refactoring. Let's create a separate file for all the basic data types, calculation, and move all the functions in that file. Let's create a new file inside src folder, new Rust file, and let's give a name basic data types and hit enter. We are going to say add in here. I'll explain what that add button exactly did in a minute. Okay, so now we do have a new file in here which says basic data types.rs. Now let's move all the functions that we just wrote from our main file to the new file. Okay, so all the functions are placed in here. Let's go to the main file. Now you can see all the functions, they are showing an error. Cannot find the function integer type in this scope. That's an error that is coming from the Rust compiler itself. So let's fix that. And to fix that, we have to import back to the add button. When we created this file, Rust rover asked us if we want to add this file in a main function. So when we clicked on the add button, what exactly happened is it added this line. This line says whenever we create a final program, this file will be part of it. Now this file is part of the program, but we are not using anything from this file. So let's fix that so that all these errors will go away. Let's use the functions from our module that we just created. And the way to use the module is use and then the name of the module, which is basic data types, colon, and star. Star is basically we are saying use everything from that module. We still have errors. Now file is imported and everything from that file also marked to be used. So Rust works a bit differently when it comes to importing file and its content. To make our example work, we have to expose our functions and we can do that using the pub keyword. So let's go back to our basic data type file and let's add the pub keyword in front of all the functions. Okay, I'm going to copy the pub keyword and I'm going to paste it in front of all the functions. This is basically the way of exposing all the functions from our module. So when we create a new file, we are creating a new module and mod keyword, it imports that module, it links that module with our binary and use keyword, it uses everything from that file. Now all the types are fixed, all the functions are fixed except the string type. Let's see. Okay, so we haven't added the pub keyword in front of string type. Let's go back to the main.rs. Perfect. This looks much better and all the errors are gone too. And our main file is free of all the clutter. So always remember, choosing the right type can significantly impact the performance and safety of your code. That's it for today. We will continue with the composite data types in our next video. Stay tuned for more videos. If you have any question or want to discuss anything, leave a comment below. And please don't forget to like, share, and subscribe. Until next time, happy coding.